Hi, this is Aramis Bermudez for Challenge 2014, and this is Interactive Learning Assignment number 3. Alright, so the first problem I'm going to do, I am going to find the maximum minimum, or the critical points of f of x equals x plus 1 over x. So the first step in finding the critical points for a function is to take its first derivative. So the first derivative of x equals 1 plus negative 1 over x squared, which equals 1 minus 1 over x squared. Alright, so we set this equal to 0. We can say that 1 equals 1 over x squared equals 1, so x equals 1 comma negative 1. So those are our two critical points according to f prime of x. Now, what we do next, in order to find out what kind of critical points they are, like maxes or mins, we're going to take the second derivative, which is 1 over x, 2 over x cubed, because this is the same thing as saying taking the derivative of x to the negative 2. So the derivative of x to the negative 2 is negative 2x to the negative 3, which in turn becomes negative 2 over x cubed. But because this was originally a minus sign in front, this changes this to a positive. So we have positive 2 over x cubed. So that's how we get that as our second derivative. Alright, so now we have this. We plug in the values that we got from the first derivative. So 2 over x cubed becomes 2 over 1 cubed, which equals 2, which is positive. Alright, then we have 2 over x cubed, 2 over negative 1 cubed, which is negative 2, which is negative. Alright, so since the concavity is positive from here, that means that the function is peaking at a certain point. So since this is positive, that means this is a minimum value. And because this is negative, it's the opposite. This is the maximum value. And that's how we find what kind of critical points these are. So the critical points for f of x are 1 and negative 1, and x equals 1 is a minimum, and x equals negative 1 is a local maximum. These are both local mins and maxes. Alright, so that's the first problem. Now the next part I'm going to do is I'm going to find the limit of a function. So the limit as x approaches 1 of the function x to the fourth minus 1 over x squared plus x minus 2 times x squared plus 3x minus 4. Alright, just give me a second. Alright, so what I figured out was the simplest way to do this was to factor out each equation on the top, on the numerator and the denominator, knock out what we know, and make sure that if there is a limit or not. So just for starters, we're going to plug in 1 for x, just to make sure in the beginning, before we knock anything out, if there's a limit or not. So if we plug in 1, we get 1 minus 1, which is 0, over 1 plus 1 minus 2, which is 0, times 1 plus 3 minus 4, which is 0. So we get zeros all around. So that means we might have to factor things out. So what I did for the next step was I separated the top into two parts. So it was x squared plus 1 times x squared minus 1 over x squared plus x minus 2 times x cubed plus 3x minus 4. Alright, we can't really knock anything out right now. So we're going to keep separating it. And if I continue to do that, I can end up with x minus 1 times x plus 1 times x squared plus 1 over x plus 2 times x minus 1 times x minus 1 times x minus 4. Alright, so what we notice is we have x minus 1 on the bottom and x minus 1 on the top, so we can knock one of each out. But we're still left with an x minus 1 on the bottom, so you can't cross it out even though there's 2. So we have to leave that 1. Alright, so now that we knocked something out and we cleared out as much as we can plug in 1 again just to double check. So 1 plus 1 equals 2 times 1 plus 1 equals 2, so we get 4 over 1 plus 2 equals 3 times 1 minus 1 equals 0. So immediately, because we have a 0 multiplied out totally in the denominator, we can assume that it's 4 over 0. So because of this, we can assume that the limit does not exist. So the limit as x approaches 1 of x fourth minus 1 over x squared plus x minus 2 times x squared plus 3x minus 4 does not exist. Alright, so the last problem, I want to find a limit of an equation that's slightly different. So the limit as x approaches 0 of tangent of x times sine of 3x over x squared. Alright, this may seem a little challenging in the beginning, but there are several identities for limits that you can use for trig functions that you can plug into here. So, for example, we know that the tangent of x over x, if the limit is, as long as the limit is approaching 0, we can assume that the limit is 1. Same thing for sine of x. So the limit as x approaches 0 of sine of x over x. As long as the limit is approaching 0, we can assume that the limit is 1 as well. As x is approaching 0, I apologize. So, like we did in the second problem, we can separate this into two different things. So this equals limit as x approaches 0 of tangent of x over x times sine of 3x over x. So we know that this one equals 1. But in this one we have sine of 3x over x. Alright, so this is where it gets pretty cool. Because there's a coefficient on the x within the sine function, we can assume that we can multiply sine of x over x times 3. So since sine of x over x, as long as the limit of x is approaching 0, is 1, we can just assume that it's 1 times 3. So this is our total thing between the tangent and the sine of 3x. So 1 times 3 is 3. So the limit as x approaches 0 equals 3. Thank you very much for your time, and have a wonderful evening.